Good day, viewers. You are welcome. How to find the value of k in this nice radical algebra where we have 2 minus k bracket 2 plus k divided by square root of 4 minus k equals 1. So to solve this, we firstly try to expand 2 minus k and 2 plus k. So when we expand that, we know this is difference of 2 square. So we just multiply the first and the last so that we have 4 minus k square divided by the square root of 4 minus k equals 1. So having this, we try to cross multiply and we have 4 minus k square equals the square root of 4 minus k. So let's try to take the square of both sides. So just to cancel this root, we have this square and this is also taking square. So when this and this cancelled, at this side we have 4 minus k square. So when we expand this 4 minus k square all square, so we are going to have something of this form as 4 square minus, here we have 2 multiplied by 4k square plus k raised to the power of 4 equals 4 minus k. So we want half here. Let's try to take all this to this left hand side. So we have 4 square minus 2 multiplied by 4k square plus k raised to the power of 4 plus k minus 4 equals 0. So having this, the next thing we are going to do here is, here we have 2 multiplied by 4k square. So I want to combine this 4 with this one so that we can have 4 raised to the power 2 minus. So after the combination of this, both are having 4. So suppose I factor out that 4. So here we are left with 2k square. Then here becomes plus 1. So we have this as k raised to the power of 4 plus k equals 0. So we cannot just be surprised that I want to make a number a variable and write it as a quadratic equation. You know, from quadratic, we have something of this form: ax square plus bx plus c equals 0. So this shows the power of algebra, where the x here is our 4. And I'm going to compare the coefficient of it with what we have. Then I will resort it in the quadratic equation so that we solve it quadratically. So here we know that a is 1 and b is the quotient of 4, which is minus open bracket 2k square plus 1, and the value of c here is k raised to the power of 4 plus k. So when we try to apply this quadratic formula, which is, we are looking for 4, and the real formula is, suppose I take capital letter B equals minus b plus or minus the square root of b square minus 4ac divided by 2a. Here is the standard formula we are going to apply. And let's try to deal with this first. We know our b, we know our a, then we know our c. But input it in this, and whereby the capital letter B here is our 4 that we are looking for. So that we have b square minus 4ac. So it's written as minus open bracket 2k square plus 1 all square minus 4 open bracket 1, which is the value of a, open bracket c is k raised to power 4 plus k. And trust me, when we expand this, the whole of this, we get 4k raised to power of 4 plus 4k raised to power of 2 plus 1. And with this one, we have it as minus 4k raised to power of 4 minus 4k. Here's what we are going to have for this. So if this and this cancelled, we are left with 4k raised to power 2 minus 4k plus 1. This is what we are going to have, where we write this as 2k minus 1 raised to power of 2. That is the expansion of it. And with this one, which is coming with the root, it means that the root of b squared minus 4ac also come with this, and this and this cancelled. When it cancelled, we have only this. So now I'm going to recall from the equation as I called b 4, so that we have 4 equals minus open bracket minus, so the value of b here is minus open bracket 2k squared plus 1 in bracket, then plus or minus. So square root of b squared minus 4ac is now our 2k minus 1. Everything divided by 2. So by cross multiplying, so 2 multiply this, and when 2 multiply this, what we are going to have here is 8 equals, so minus times minus, it becomes plus, and here becomes 2k squared plus 1. Then plus or minus 2k minus 1. So there are two different cases here. So it is better I put this in brackets. So there are two cases. So the first case is we consider the plus. So let's just write case 1. So when we consider plus, it means we are going to have 8 equals 2k squared plus 1 plus 2k minus 1. So plus 1 cancels plus 1. And here we have 8 equals, so 2 is common. Taking it out, we have 2 open bracket k squared plus k. So when 2 cancels this, we have this as 4. While the over all of these becomes k squared plus k. So by taking 4 to the other side, it becomes minus, and everything equals 0. So we get another quadratic equation. But with this one, when we try to solve this using the quadratic formula, so we get the value of k equals minus 1 plus or minus square root of 17 divided by 2, as we consider this as k1, k2. While for the second part of this, which is when we consider the negative from here, we are going to have it as 8 equals 2k squared plus 1 minus open bracket 2k minus 1. So having this one, we have this as 8 equals 2k squared plus 1. Then the expansion of this is minus 2k plus 1. So here we have 8 equals 2k squared minus 2k plus 2. So we try to take this one here, or let's say we divide both sides by 2 first, as we did earlier. We have this as 4 equals k squared minus k plus 1. Then here becomes k squared minus k minus 3, everything equals 0. So on getting this, we also try to solve it by quadratic equations. And the end result we get for this one also is 1 plus or minus the square root of 13 divided by 2, and we consider it as k2 comma k3 comma k4, which is 4 solutions. But with all this, not all of them satisfy. So it is only 2 that satisfy this problem, and I need the answer in the comment box. Thanks for watching, and thanks for always engaging in our video. Never stop learning. Those who stop learning stop living. See you in the next class. Bye bye.